So the maximum value is 18 at 4 comma 3. So if you do this much, definitely you will get 6 marks. Okay. Now you know for the function to be maxima or minima, dy by dx is equal to 0. That is first derivative must be equal to 0. Second row and third row are same. First row is to be changed by taking r1 dash is equal to r1 plus r2 plus r3. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, Temple of Excellence. Now in my previous class, we have discussed regarding the model paper for 2021 and 22. In that we have discussed part A, part B, part C and part D. Now today I am going to discuss the last part, that is very important and easiest part, that is part E. We have one 6 marks question and one 4 mark questions. In part E, you are going to answer only one question. So first question carries 6 marks and second question carries 4 marks. Let me discuss with this problem. So this is for 6 marks. This is a 6 marks question. 6 marker. Now in part A, you know you will have 6 marks plus 4 marks, totally 10 marks. In this you are going to answer for one question. Let us come to the first problem. What is the problem? 64a. Maximize z is equal to 3x plus 2y subjected to the constraints x plus 2y is less than or equal to 10, 3x plus y is less than or equal to 15 and xy is greater than or equal to 0. This is the problem given. Just see this, don't see this solution. You just see the problem. What is problem? Maximize z is equal to 3x plus 2y subjected to the constraints x plus 2y is less than or equal to 10, 3x plus y is less than or equal to 15 and x comma y greater than or equal to 10. Now, let us convert this. This is the objective function. What is the objective function? The objective function here is max z. You have to maximize. Max z is equal to 3x plus 2y. Subjected to the constraints. What are the constraints? These are the constraints. Now, convert these inequalities into equalities. Let us convert the inequalities into equalities. Now how to convert? Just write x plus 2y is less than or equal to 10 can be written as equal to 10. And similarly, second equation is 3x plus y is less than or equal to 15 can be written as 3x plus y is equal to 15. Just find out the points for this. Now let me solve this. Now I'll take the first equation. What is the first equation? X plus 2y is equal to 10 and other equation. What is the other equation we have? 3x plus y is equal to 15. Now just put x is equal to 0. If you put x is equal to 0, then this is 0 plus 2y is equal to 10. 2y is equal to 10. Y is equal to 10 by 2 is 5. So therefore the first point, a is equal to 0 comma 5. Now put y is equal to 0. Now put y is equal to 0. Then this is x plus 0 is equal to 10. X is equal to 10. So therefore the coordinates of b is equal to 10 comma 0. So these are the points for the equation first line, for the line x plus 2y. Now I will write here for the line. What are the points we got? So this is x and y. When x is equal to 0, y is equal to 5. When x is 0, y is 5. Again, when x is equal to, y is equal to 0, x is equal to 10. So when y is 0, x is equal to 10. These are the points. Now let us similarly solve the second equation. What is the second equation? Same, 3x plus y is equal to 15. Same procedure. Put x is equal to 0, you will get y is equal to 15. Therefore, the coordinates of C are 0 comma 15. Now, similarly, put y is equal to 0, you will get 3x is equal to 15, x is equal to 15 by 3, that's equal to 5. So, therefore, the coordinates of D, point D is equal to 5 comma 0. D, this is D. Now, so what is C? 0 comma 15. What is D? 5 comma 0. Now let us represent here for the second equation. What are the points we got? This is x and y. When x is 0 and y is 0. When x is equal to 0, y is 15. 0 comma 15. Again 0 comma 15, and y is equal to 0, it is 5 comma 0. So these are the coordinates. Okay, this is how we are going to get the points. Okay, now let us represent this on a graph. Now let us take this is x-axis and y-axis. Let us consider a suitable scale. On the x-axis 1 centimeter is equal to 1 unit, and on the y-axis 1 centimeter is also equal to 1 unit. On the x-axis 0, 1, 2, 3, 4, 5 up to 10, maximum 10. And on the y-axis, let us consider what is the maximum value. We have 15. Okay, we have 15 maximum value. Now the first point, what is A? A is equal to 0 comma 5 and B is equal to 10 comma 0. C, what is C? C is equal to 0 comma 15 and D is equal to 5 comma 0. Okay, see, these are the points. So let me check. 0, 5, 10, 0 and C. What is C? 0 comma 15 and 5 comma 0. Okay. Now let us represent this on a graph. First point, what is A? 0 comma, x is 0, y is 5. This is A, 0 comma 5, and y is equal to B. What is B? B, 10 comma 0. X is equal to 10 and y is equal to 0. This is point B, 10 comma 0. Okay, right. Now let us draw a line. Just draw a line which passes through these 2 points. Okay, now that is here A and this. This will intersect the x-axis at 10 y. So since what is the curve given? The equation is, first equation is x plus 2y is less than or equal to 10. Less than or equal to 10, which indicates the feasible region is towards the origin. So it will goes in the downwards direction like this. Now for the second curve, what is the second curve? We have point C is equal to 0 comma 15 and D is equal to 5 comma 0. So here C 0 comma 15, x is equal to 0, y is equal to 15. Somewhere it will goes like this. Let us represent this is 0 comma 15. Okay. Now and D, what is D? D is 5 comma 0. This is 5 comma 0. Okay. Now just draw a straight line which passes through like this. Now this is the curve actually we are going to get. Now if you want, I will write, I will show it here. See here like this. This is x-axis and y-axis 0 comma 0. Let us take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what is the first point? A. A is equal to 0 comma 5. X is 0, y is 5. 1, 2, 3, 4, 5. This is A, 0 comma 5. And B, 10 comma 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is B. So you can draw a straight line like this. So this is less than or equal to. So it feasible region is towards the origin. Now similarly for the second equation, C is equal to 0 comma 15. X is 0, y is 15. Somewhere you will get a point like this. And D, y comma 5 comma 0. 1, 2, 3, 4, 5. This is the point 5 comma 0. Just draw like this. Since again this equation, what is this equation? The equation is 3x plus y is less than or equal to 15. Less than or equal to 3x plus y is less than or equal to 15. The feasible region is towards the origin. So therefore this is the feasible region and this is the point of contact. Now let us represent this as E. So if you solve carefully, so the point you are going to get here, I have drawn here. So that is 1, 2, 3, 4, x is equal to 4 and this is the point and x is equal to 3. So this is 4 comma 3. So you will get 4 comma 3 as the point. Okay, that is what I have written here. So therefore the corner points are O 0 comma 0, A 0 comma 5 and E 4 comma 3 and D 5 comma 0. So these are the corner points. So the corner points are, what are the corner points? 0 comma 5, 4 comma 3, 5 comma 0 and 0 comma 0. So therefore the corner points are O 0 comma 0, A A, what is A? 0, comma 5. Then E, 4, comma 3. And D, what is D? D, 5, comma 0. So these are the corner points. Okay. Let us represent this. Corner points. Then Z, the objective function. What is Z? Z is equal to 3x plus 2y. Now, let us take the corner points. First one at O, 0, comma 0. Second one A, 0, comma 5. Third one E, 4, comma 3. And fourth one D, 5, comma 0. Now find out the values of Z, that's it. Okay. Now at 0, comma 0, Z is equal to 0 plus 0 is equal to 0. This is 0. Now at A, 0, comma 5, put x is equal to 0, that is 3 into 0 plus 2 into y is 5, that's equal to 10. This is 10. Next at, what is the point? At E, 4, comma 3, Z is equal to, substitute here 3 into 4 plus 2 into 3, that's equal to 3 4s are 12 plus 2 3s are 6, that's equal to 18. This is 18. Now at last point D, what is D? 5, comma 0, Z is equal to 3 into 5 plus 2 into 0, that's equal to 15. So these are the values of Z, 0, 10, 18 and 15. Now what do you say from this table? What is required to find is the maximum. Where it is maximum? What is the maximum value? This is the maximum value. Now from the table, this is maximum. So therefore the maximum value is 18 at 4, comma 3. So therefore Z maximum is equal to 18. Now conclude it. Therefore the maximum value Z maximum is equal to 18 at, what are the points? At E, 4, comma 3. That's it. So the maximum value is 18 at 4, comma 3. So if you do this much, definitely you will get 6 marks. Okay. You just plot this graph like this, follow the graph, and these are the corner points. This is the feasible region, and find out the solution. So the function is maximum at the Z maximum value is equal to 18 at this point E, 4, comma 3. That's it. Okay. This is how we are going to solve the graph. So if you do this much, you will get 6 marks. This type of questions are very, very important and very easy to get 6 marks. Okay. Now then, followed by this, you will have one more 4-mark question for this. If you answer this, 4-mark question is again compulsory for you. Now what is the 4 mark? This is compulsory question, you have to answer. So if part B, this carries 4 marks. Now if the matrix A is equal to 2, 3, 1, 2 satisfy the equation A square minus 4A plus I is equal to 0, where when I is, or where I is 2 cross 2 identity matrix and O is nothing but a 0 matrix of order 2 cross 2, using this equation find A inverse. Here majority of the students get confused with this problem. Just they will put A square minus 4A is equal to I and simplify finding the value of A square 4A and I 100, and they will show that this is equal to 0. That is wrong. Don't do like that, because here already given. What is given? This will satisfy the condition, Cayley-Hamilton theorem. A square minus 4A plus I is equal to 0. The condition is satisfied. This is already 0 given. If such is the case, find out the value of A inverse without using any formula like finding the inverse 1 over determinant A into adjoint. Without using any formula of inverse, we have to find out the inverse for this matrix using the given equation a square minus 4a plus I is equal to 0. Now, what is given equation? The given equation is a square minus 4a plus I is equal to 0. Now, here for this problem, we must be familiar with these properties. You know, if A is any matrix, an identity matrix, or I is identity matrix into A, if you multiply any matrix with an identity matrix, or identity matrix is multiplied by any matrix of same order, you will get the same matrix. And suppose if you multiply a matrix with the inverse, or A inverse into A is always equal to an identity matrix. A matrix into an inverse is equal to an identity matrix. These two properties we are making use of this. Now multiply by A inverse. Multiply by A inverse on both sides. Then what you will get? A inverse into A square minus 4 A inverse into A plus A inverse into I is equal to 0. Let us write A square into A into A into A inverse minus 4A inverse plus I into A inverse is equal to 0. Now, this can also be written as A into A inverse minus 4 A inverse plus I into A inverse. Since you know A into, what is A inverse? A inverse is equal to an identity matrix, because A inverse is equal to an identity matrix, minus 4 into again A inverse is equal to an identity matrix, plus what is I into A inverse? Any matrix into identity matrix is equal to same matrix. I into A inverse is equal to A inverse is equal to 0. Right. Now, what is A into I? A into I is equal to A. So, AI minus 4I plus A inverse is equal to 0. Now, what is A inverse? A into I. Since A into I is equal to A itself. A minus 5I plus A inverse is equal to 0. This is the equation we are going to get. Now, from here you can solve easily. Okay, see here. Just multiply by A inverse. A square can be written as A into A inverse 4 A inverse plus IA inverse is equal to 0. This can be written as A inverse is equal to I. 4 into A inverse is I, and again A into I inverse is equal to A inverse. So, A into I will go to the next page. A into I minus 4I plus A inverse. A into I is A, 4I plus A inverse is equal to 0. See here. Now, what is required to find is A inverse. Keep A inverse and transfer minus 4I to the right hand side. Minus becomes plus 4I and plus A becomes minus A. Now, A inverse is equal to 4 into what is identity matrix? 1 0 0 1 of order 2 rows 2 column, and what is the matrix given? A is equal to 2 3 1 2. 2 3 1 2. Simplify this. This is 4 0 0 4 minus 2 3 1 2. Subtract this. 4 minus 2 is 2. 0 minus 3 is minus 3. Again 0 minus 1 is minus 1. 4 minus 2 is 2. So, therefore, the inverse, the required inverse, A inverse is equal to 2 minus 3 minus 1, and that's all. This is the inverse for the given matrix, that's all. So, if you do this much, definitely you will get 4 marks. So, totally 6 plus 4 is 10 marks. Very easy to get 10 marks from this part. Okay. So, that is regarding this problem is concerned. Now, let us come to the next problem. What is next problem? So, that is from properties of definite integrals. So, you will get one question from properties of definite integrals for 6 marks. Along with that, for 4 marks, you may get any question from continuity and differentiability or from properties of determinants. Now, let us come to this problem. What is A? This is again a 6 marks question. Prove that 0 to A f of x dx is equal to 0 to A f of A minus x dx, and hence evaluate 0 to A root x by root of x plus root of A minus x dx. This is also a very simple problem and very important type problem. Now, let us prove this. Now, to prove that, first part, to prove that integral 0 to a f of x dx is also equal to integral 0 to a f of a minus x into dx. Okay. Now, let us start with the RHS. Now, RHS, what is RHS? Here 0 to a f of a minus x into dx. Now, let us take put t is equal to a minus x. Put t is equal to a minus x. Okay. Now, differentiate it. Differentiating with respect to x, dt by dx is equal to a constant 0, differentiation of x is 1. So, this is equal to minus 1, cross multiply it, dt is equal to minus dx or minus dt is equal to dx. Now, you know, whenever the substitutions are taken, the value of limit also changes. What are the values of limit here? 0 to a. Now, listen. Whenever the substitutions are taken, the value of limit also changes. What is lower limit? 0. What is upper limit? A. What is the substitution we have taken? T is equal to a minus x. Now, when lower limit x is equal to 0, substitute here. T is equal to a minus 0 is equal to a. When upper limit, what is upper limit? A. When x is equal to a, t is equal to, substitute here, a minus a, that's equal to 0. So, limit 0 to a becomes a to 0. So, this given integral will reduce us to integral 0 to a can be written as a to 0 f of, what is a minus x? A minus x is t, and what is dx? Dx is equal to minus dt. Dx is equal to minus dt. Okay, see here. Let us consider RHS, very simple. RHS 0 to a f of a minus x dx. Put t is equal to a minus x. Take the substitution, t is equal to a minus x. Differentiate it, dt by dx is equal to derivative of a is 0, x is minus 1. Minus 1, so just cross multiply, dt is equal to minus dx or minus dt is equal to dx. Again, whenever the substitutions are taken, the value of limit changes. What is the substitution? T is equal to a minus x. The lower limit, when x is equal to 0, t is equal to a minus 0 is a, lower limit reduces to a, and the upper limit x is equal to a, substitute here, a minus a is equal to 0, upper limit becomes 0. So, the lower limit 0 to a reduces to a to 0, and f of a minus x is t, dx is equal to minus dt. You can take minus out. So, if you take minus out, this can be written as minus a to 0 f of t and dt. Now, you know there is one property. From property, integral a to b f of x dx is also equal to integral b to a f of x dx. Whenever the limits are changes, it will changes the sign. So, a to b becomes b to a, and this integral will converts in sign, that is plus becomes minus. So, I can write, if you interchange the integrals, a to 0 can also be written as 0 to a, and this minus becomes plus f of t into dt. Okay. Now, on the other hand, there is one more formula. We know that since there is one formula, integral a to b f of x dx is also equal to integral a to b f of t dt. So, therefore, this can also be written as 0 to a f of t dt can also be written as 0 to a f of x dx. This is what the required LHS. See, 0 to a f of x dx, that is all. Very simple. So, a to 0 f of t minus dt, take this minus out, a to 0 f of t dt. Whenever the integrals are changed, if lower and the upper limits are interchanged, the integral value changes in sign. So, that means minus becomes plus here. See, this is the property, a to b f of x dx is also equal to minus b to a f of x dx. So, a to 0 can also be written as 0 to a f of t dt, and this minus becomes plus. Further, we have one more formula, that is, since integral a to b f of x dx is also equal to a to b f of t dt. So, therefore, 0 to a f of t dt can also be written as 0 to a f of x dx. That is what required to prove. That is Rh. Therefore, integral 0 to f of x dx is also equal to 0 to a f of a minus x into dx. That's it. That is to be proved. Now, if you do this much, you will get 3 marks. And for the second part, to evaluate, if you do this, again remaining 3 marks you will get. Totally 3 plus 3, 6 marks. Now, let us come to the second part. Now, to prove that, now to evaluate integral 0 to a root of x divided by root x plus root of a minus x dx. This is to be evaluated. Check x by root of x plus root of a minus x dx. Now let us consider this as I. Let I is equal to 0 to a root of x divided by root of x plus root of a minus x dx. This is equation number 1. Okay. Now let us change x to a minus x, upper limit minus x. Now just put x is equal to a minus x. Then this equation I is equal to integral 0 to a root of x can be written as a minus x divided by root of x is nothing but a minus x plus root of a as it is minus x can be written as a minus x into dx. So this is equal to I is equal to integral 0 to a, numerator is same, a minus x divided by root of a minus x plus root of, multiply by negative sign, minus a minus into minus plus x dx. So therefore I is equal to integral 0 to a root of, numerator is same, a minus x divided by root of, denominator a minus x under root plus root of, here minus a plus a gets cancelled, you will get x dx. Let us represent this as equation number 2. See equation 1 and 2, wherever x you have a minus x in equation number 2. So in equation number 1 we have x in the numerator, here we have root of a minus x, here x we have a minus x and a minus x is converted into x. Adding 1 and 2. So left hand side I plus I is equal to integral 0 to a, what is equation number 1, root x divided by root x plus root of a minus x dx plus equation number 2, what is equation number 2, we have 0 to a root of a minus x divided by root of a minus x plus root of x dx. See, this is equation number 2, a minus x by a minus x plus. Now I plus I is equal to 2i. So 0 to a. Now just take, this can be written as 0 to a, take LCM here, root of x plus root of a minus x into dx. This 2 gets cancelled, you will get x. Again this 2 gets cancelled, you will get root of a minus x. Just take LCM and simplify. So what happens? This is 2i is equal to, this 2 gets cancelled, 1 into dx is dx between limits 0 to a. So integration of dx is x between limits 0 to a. So just apply the upper limit is a minus 0, that is equal to a. So 2i is equal to a, therefore I is equal to a by 2. Now therefore conclude, what is I? Therefore integral 0 to a root of x divided by root of x plus root of a minus x dx is equal to a by 2. This is the answer, that's it. So what is the answer? Just the required answer is a by 2, very simple. So if you replace x by a minus x, you will get equation number 2. Adding 1 and 2, take LCM and simplify. X plus root of a minus x plus x plus root of a minus x is the LCM. This 2 gets cancelled, root x. Again this 2 gets cancelled, root a minus x. Numerator and denominator are same, gets cancelled. 1 into dx is dx. Integration of dx is x between the limit 0 to a. Apply the upper limit. A minus 0 is a. 2i is equal to a. I is equal to a by 2. That's it. So if you do this much, you will get 6 marks. 3 plus 3, 6 marks. Now one more question for this is 4 marker question. That is from continuity. So this is also very important. From continuity we have one more question for 4 mark. What is given? Find the value of k so that the function f of x is equal to kx plus 1 if x is less than or equal to 5 and 3x minus 5 if x is greater than 5 is continuous at x is equal to 5. It is already given, it is continuous at x is equal to 5. Then what is required to find is just to find the value of k, that's all. Here x is equal to 5 means at a is equal to 5 when x is less than 5, when x is less than 5, you will get f of x is equal to kx plus 1. When x is, therefore you will get the left hand limit, The left hand limit, what is left hand limit? The left hand limit is limit x tends to a minus x tends to 5 of f of x. So this is limit x tends to 5 of, what is f of x? F of x is kx plus 1. So this is equal to, if you apply, put x is equal to 5, then you will get 5k plus 1. Now similarly, when x is less than 5, you will get left hand limit. When x is greater than 5, when x is greater than 5, f of x is equal to, what is f of x? 3x minus 5. So therefore you will get right hand limit. Right hand limit is equal to limit x tends to 5 minus f of x. So that is equal to limit x tends to 5 minus, what is f of x is 3x minus 5. Put x is equal to 5, 3 into 5 minus 5, that is 15 minus 5 is equal to 10, left hand limit. Now when x is equal to 5, when x is equal to 5, f of x is equal to kx plus 1. So therefore f of 5 is equal to 5k plus 1. So these are the values. Now since what is given, it is continuous at x is equal to 5. Okay, just find out the left hand limit, right hand limit and functional value. But the given condition, what is given? Since f of x is continuous at x is equal to 5, therefore left hand limit is equal to right hand limit is equal to functional value. Right, if the function is continuous means all left hand limit, right hand limit must be equal to the functional value. So what is left hand limit? 5k plus 1. What is right hand limit? Right hand limit is equal to 10. And what is f of a? The functional value f of a, that is nothing but f of a, that is f of a is equal to f of 5, that's equal to 5k plus 1. 5k plus 1. That's it. This is given. So left hand limit is equal to right hand limit is equal to functional value. Now just equate first and second or second and last. Let me take first and second. 5k plus 1 is equal to 10, or 5k is equal to 10 minus 1 is 9. Therefore k is equal to 9 by 5. That's it. So the value of k is 9 by 5. That's it. Very simple. This is how we are going to solve the problem. Okay. Or you can straight away write, since f of x is continuous, since f of x is continuous at x is equal to 5, therefore left hand limit is equal to right hand limit is equal to functional value, that is limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to the functional value. Substitute here, just if you substitute, that is limit x tends to 5 of f of x. What is f of x? Kx plus 1 is equal to limit x tends to 5 of f of x for greater than 3x minus 5. Functional value, what is f of x? Kx plus 1. This is equal to kx plus 1, where x is equal to 5. So if you put, you will get 5k plus 1 is equal to 5 3s are 15 minus 5, 5k plus 1. So 5k plus 1 is equal to 10 is equal to 5k plus 1. Consider the first and second. 5k plus 1 is equal to 10. 5k is equal to 10 minus 1. K is equal to 9. This is the step. You can follow straight away or step by step find out the value. That's it. Okay, this is how we are going to solve this limit. Now let us come to the next problem. So this is also a very important problem indeed. So for 6 marks, this is from application of derivatives, that is maxima and minima. Now prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27. This is to be proved. This is the answer. So prove that the volume of the largest cone, the volume of the largest cone, this is the cone, the volume of the largest cone that can be inscribed in a sphere of radius r is the radius of the sphere, then is 8 by 27 of the volume of the sphere. Now very simple, here we are going to use the concept of volume of a cone. That's it. Now let us consider, this is the diagram given. Let us consider a circle of radius r. R is the radius. OR is equal to R is the radius of the sphere. Let small r is the radius of the base. Let R be the base radius. Then h is the height and v is the volume of the cone. See here, let us consider a cone of radius OB is equal to R is the radius of the sphere and small r is the radius of the base and h is the height and v is the volume of the cone. Okay. Now, from this triangle, let us consider this triangle AOC. From this triangle, if you apply the Pythagoras theorem for this, you can write here OC square is equal to OA square plus AC square. That is, OC square is equal to AO square plus OC square. From Pythagoras theorem, OC square is equal to OA square plus AC square. Okay. Now, what is that AO? This A to O, AO can also be written as the total distance h minus the radius. Total distance is h and r is the radius, h minus r. So, AO is equal to h minus r and AC is nothing but radius of the circular base and OC is equal to O to C is nothing but the radius of the cone. Now, h minus r whole square plus r square is equal to r square. So, this is an equation of two variables r and h. Now, simplify this. Now, a minus b whole square can also be written as a square plus b square minus 2ab plus r square is equal to capital R square. Now, transfer this. This can also be written as h square plus r square minus 2rh plus r square minus r square is equal to 0. Minus r square plus r square gets cancelled. H square minus 2rh plus r square is equal to 0. Right. Now, therefore, r square is equal to transfer this. Minus 2rh becomes plus 2rh minus h square. Let us represent this as equation number 1. R square is equal to 2rh minus h square. Now, we know the volume of the cone. Volume of the cone V is equal to, what is the volume? Volume is equal to 1/3 pi r square, h is the volume of the cone. Now, use this. Now, volume of the cone V is equal to, now the volume V is equal to 1/3 pi r square h. What is r square? This is r square. Substitute the value of r square. 2, that is 1/3 pi into, what is r square? 2rh minus h square into h. Okay. Simplify this. This is 1/3 pi times, simplify, 2rh square minus h cube. Now, this is the volume. Let us represent this as equation number 2. Okay. See here, last from this equation, if you apply a minus b whole square, AO square plus AC square is equal to OC square, h minus r square plus r square is equal to capital R square, a square plus b square minus 2ab plus r square is equal to capital R square, transfer minus r square and plus r square gets cancelled. So, h square minus 2rh plus h r square is equal to 0 or r square is equal to plus 2rh minus h square. Substitute this value of r in the volume. The volume of the cone is 1/3 pi r square h. The volume of the cone is 1/3 pi r square h. 1/3 pi into r square is 2rh minus h square into capital H. Multiply, just keep this constant, 2rh into h is h square into h is h cube. Let us represent this as equation number 2. Okay, this is the volume. Now, let us differentiate this with respect to h. Differentiating with respect to h. Now, what we will get? dV by dh is equal to 1/3 pi constant. We are differentiating with respect to h. So, here 2r is a constant and differentiation of h square is 2h minus differentiation of h cube is 3h square. Differentiating with respect to h. Now, differentiate again with respect to h. Differentiate again with respect to h. What you will get? This is d square v by dh square. So, this is v dash and v double dash. Now, so 1/3 pi as it is, 1/3 pi into 2r as it is, differentiation of 2h is 2 into 1 is 2 minus 3 constant, differentiation of h square is 2h, that is 6h. So, this is equal to 1/3 times pi into 2 to the 4 times capital R minus 6h. This is second derivative. Okay. dV by dh, d square v dash and v double dash. Now you know for the function to be maxima or minima, dy by dx is equal to 0. That is first derivative must be equal to 0. For the function to be maxima or minima, dv by dh is equal to 0. Equate this is equal to 0, you will get the value of h. Substitute here and check whether it is maximum or minimum. If d square v by dh square is positive, then it is minimum. If d square v by dh square is negative, then it is maximum. That's it. For the function to be maxima or minima, that is dv by dh is equal to 0. That is v dash is equal to 0. V dash is equal to 0 means 1 over 3 times pi into 2. 1 over 3 times pi into this 2 into 2. That is 2 into 2 is 4 times r h minus 3 h square is equal to 0. If you cross multiply, you will get 4 rh minus 3 h square is equal to 3 into 0. If you multiply 3 into 0, 0. Again 0 by pi is 0. So you will get 4 rh is equal to 3h square. Right. What is required to find is the value of h. So therefore, one h and h gets cancelled. 4r is equal to 3h. Therefore, h is equal to 4r divided by 3. The value of h is equal to 4r by 3. Now, if you put h is equal to 4r by 3 in this equation number, now when h is equal to 4r by 3, this v double dash, that is d square v by dh square is equal to, substitute here 1 over 3 pi into 4r minus 6 times h. What is h? 4r by 3. So this is 3 2 gets cancelled. 1 over 3 times pi into 4r minus 8r. This is equal to 1 over 3 times 4r minus 4r. That is minus 1 over 3 times pi into 4r. That means this is negative. If this is negative means therefore the function is maximum. Therefore the function is maximum at what is the value? H is equal to 4r by 3. That's all. Therefore the function is maximum at 4r by 3, h value. That's it. See, just find out the value of first derivative, just differentiate it and equate it to 0, you will get the value of h, and substitute that value in the second derivative. If it is negative, function is maximum. If it is positive, the function is minimum. So here the function is maximum. Therefore the maximum value is got by putting h is equal to 4r by 2 in equation number 1. Now the maximum value is got by putting h is equal to 4r by 3 in equation number 2. What is equation number 2? This is equation number 2. V is equal to 1 over 3 pi. V is equal to 1 over 3 times pi into 2r h square minus h cube. Substitute here. That's it. So this is 1 over 3 times pi into what is h? 2r into h is equal to 4r by 3 minus h cube is 4r by 3 whole cube. If you simplify, you will get the answer. That's it. So what is V? V is equal to 1 over 3 pi times 2r h square minus h cube. Just substitute the value of h. What is h? H is equal to 4r by 3. Substitute here. This is 1 over 3 into pi 2r into h, 4r by 3 whole square minus 4r by 3 whole cube. It is square and cube. Okay. Now simplify this. Therefore V is equal to 1 over 3 times pi 2r into, this is 4 for the 16 r square divided by 3 square is 9 minus 4r by 3 whole cube. 4 4 is 16, 16 4 is 64, 64 r cube divided by 3 3 is 9, 9 3 is 27. So this is 1 over 3 times pi into 16 into 2, 32. 32 r cube by 9 minus 64 r cube by 27. Now let us take LCM. 1 over 3 pi times 27 is the LCM. So if you divide 27 by 9, it will cancels by 3 times. 32 into 3. That is nothing but 96. So this is 96 r cube. 27, 77 gets cancelled. 64 r cube. So this is equal to 1 over 3 times pi into 27 LCM. As it is, simplify. 96 minus 64. 6 minus 4 is 2 and 9 minus 6 is 3. 32 r cube. This can be written as 1 over 3 pi into, simplify this, 32 can also be written as 8 into 4 r cube divided by 27. So this can be written as 8 by 27 into, this 8 by 27 into 4 by 3 pi r cube. See, 8 by 27 into 4 by 3 pi r cube. Okay. Now what is this 4 by 3 pi r cube? This is nothing but the volume of a sphere. Therefore, this can be written as 8 by 27 into volume of a sphere. 8 by 27 into volume of a sphere. What is the conclusion now? Now what is the conclusion? Therefore, V is equal to 8 by 27 times the volume of sphere. So the volume of a cone is equal to 8 by 27 times the volume of a sphere. So that is the final conclusion part. So that is what to be proved. That is the volume of, the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 times the volume of the sphere. So therefore the volume of a cone is equal to 8 by 27 times the volume of a sphere. That's it. So this, if you do, you will get 6 marks. Okay, right. Here the number of steps are more. If you are familiar with the problem, then only solve this. Otherwise, go for definite integrals or LPP. Usually 90% you will expect the question from linear programming. Better to solve that. Now, the last in this is for 4 markers. Now, by using properties of determinant, show that A minus B, 2A, 2A, 2B, B minus C minus A, 2B, C, 2C, C minus A is equal to A plus B plus C whole the cube. This is also very important and easiest problem. Now, let us take LHS. LHS is equal to A minus B minus C, 2B, 2C, 2A, B minus C minus A, 2C, 2A, 2B, C minus A minus B. Now convert this in such a way that all the elements above or below the principal diagonal must be equal to 0. Then using the property of determinant, you can evaluate it. That's it. Now let us convert the first row. Now taking R1 dash is equal to R1 plus R2 plus R3. So listen to me here, just we are changing row 1, that's all. This is row 1, this is row 1, row 2 and row 3. We are changing row 1, row 2 and row 3 are same. Row 2, 2B, B minus C minus A and 2B, and row 3 is 2C, 2C and C minus A minus B as it is. Add first element of R1, that is A minus B minus C, plus first element of row 2, that is 2B, plus first element of row 3 is 2C. Similarly add this, that's it. 2A plus B minus C minus A plus 2C, and add this first element last, that is first element, second element and third element. So 2A plus 2B plus C minus A minus B. Okay. Second row and third row are same. First row is to be changed by taking R1 dash is equal to R1 plus R2 plus R3. First element of row 1, first element of row 2, first element of row 3. A minus B plus 2B plus 2. Again second element of this. Second element of row 1, row 2, row 3, 2B plus B minus C minus A plus. Again third element of row 1, row 2, row 3, that is you will get. So if you simplify, what happens, see. So here A as it is, plus 2B minus B is 1B, plus 2C minus C is 1C. So you will get here as A plus B plus C, and this is same 2B 2C as it is. Similarly in the second row, so 2A minus A is A, 2C minus C is C and B, 2 that is nothing but A plus B plus C and B minus C minus A and 2C. Now for the third column again 2A minus A is A, 2B minus B is B plus C, A plus B plus C, A plus B plus C, 2B and C minus A minus B. Now simplify this. If you simplify, you get the answer. Now convert this. Now you can take the common factor. A plus B plus C is the common factor in the first row, 1, 1, 1. The remaining is 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B. Okay. Now taking C2 dash is equal to C2 minus C1. This C1 as it is, this minus, then C2 dash is equal to C2 minus C1. Similarly, C3 dash is equal to C3 minus C1. So what happens? This can be written as A plus B plus C into, we are changing the column 2 and column 3. So first column is same, first column 1, 2B, 2C as it is. C2 minus C1, subtract this, 1 minus 1, 0. See here, B minus C minus A, B minus C minus A minus 2B. What happens? Minus A, minus 2B plus B is minus B minus C. You can take minus out, A plus B plus C. So this can be written as minus of A plus B plus C and 2C minus 2C, 0. Similarly, C3 minus C1, these two. 1 minus 1, 0. 2B minus 2B, 0. C minus here, C minus A minus B minus 2C. So what is this? So this is minus A minus B minus C. You can take minus out A plus B plus C. So this is minus of A plus B plus C. So if you observe carefully, all the elements above the principal diagonals are zeros. So therefore the value of determinant is equal to product of principal diagonal elements, A plus B plus C into 1 into minus of A plus B plus C into minus of A plus B plus C. So what is this equal to? This is equal to, I'll write here, A plus B plus C into minus plus, A plus B plus into A plus B plus C is A plus B plus C whole square. This is equal to A plus B plus C whole cube. That is your required RHS. That's it. So the answer is A plus B plus C whole cube. See, that's it. Convert all the elements above the principal diagonal as zeros. Then you will get the product of principal diagonal elements as the value of the determinant. 1 into minus A plus B plus C into minus A plus B plus C is minus of minus plus A plus B plus C whole square. A plus B plus C whole square into A plus B plus C is A plus B plus C whole the cube. That's it. So that's regarding this 4-mark question. So these are all a few problems from the model question paper. My dear students, hope you followed this. Just practice, practice, practice. If you practice this model paper, definitely you will get maximum marks from this type of questions. So hope you followed all these type of questions, including 1 mark, 2 marks, 3 marks, 4 marks, 5 marks, as well as 6 marks from all the parts, part A, part B, part C, part D and part E. So hope you will follow this. You practice, you will get the marks. Okay. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.